Okay, so welcome everyone to this new stream of EagleFly, the experimental debugger. And well, today is a weekend, and I love weekends. It's a perfect day to code. So let's start with that. With that in mind, I will open for coder. Let me let me compile, and let's see where do we put all this stuff. Alright, I will open the debugger. And this time didn't took too long as the last time, probably because it has some cache. But man, it shouldn't take that long, even though it has to be fast, man. It has to be, man, like like the speed of light. And yeah, I mean, it all depends on how much well, I mean, I don't know how this Visual Studio it's being constructed and architected, but I mean, something that you have to take. Especially we, as we make this debugger, we want to take into consideration the how fast. I mean, yeah. I mean, of course, the performance, of course, after all, and also usability. Uh, and even though I mean, since we're starting, we don't have to care too much right now for performance. We should at least have the idea or have sense uh, of architect the code in a certain manner, so we can start to see. So well, I mean, probably it's difficult, I know, but uh, I mean, not all the code is gonna have this kind of performance regs or uh, performance cases that you have to uh, take into account. But they're most like these specific cases where uh, it's better just to take the effort once we have gotten to the point where the code has already gotten to a bad performance state, where we can start to do this kind of debugging process and start to find out these specific bottlenecks that we can fix and adjust the code to to solve the problem. And I think, I mean, that's a better way to go instead of trying to get performance right now, because I mean, what we're gonna perform about? We haven't written any code at all. So yeah. So let's run this step. so we can take a look at where we are at. And you know, the last thing that we did was that we we print this text uh, with the Mr. Schomburg's library STV to type. And now I think, but you know, we have some kind of problems, and I mean it's kind of easy to see that we haven't handled yet how to space correctly the each letter, you know. I mean, I just if I remember, I just said to use the X bands, and that's all, without without making consideration of the left side variant or whatever, you know, and the kerning. So I think that's the thing that we should do today. I don't think it should be too much, and you know, let's go to the place where we left off that place, and I think it's in right here. We have render text, and this render text is gonna be how can I say, basically this is the idea of how the usage code wants to render some text, you know, like, oh, give me the text, and I'll basically render it. And here we say, yeah, we have edge advanced and we don't have any kerning spacing at all, so we can start by doing that. And let me see how can we get the kerning using STV. I believe I have it here. Let me erase all this code that we made to test the thing that we were testing yesterday. If I believe, yeah, we were doing this. There you go. Need that. This is the can of the. Yeah, we also want to take a look at. We were using this code, but we haven't understand what does it do, because it seems to grab. I mean, it should get I mean, this is the bitmap box, you know. No, this is not the problem. This one is the problem. We use the width minus the high for a particular scale that we got, and then we render that using the width and high for a particular scale using the code point, which I believe, I mean this code should be relative. It will be equal to the one that we use now, that's get code point bitmap, you know. But something weird in there, you know, like we don't care too much about that, because I mean the only thing that we want is to grab to render the bitmap and to we probably we want the my question should be like, if it's necessary, should we have sufficient to render, we render the bitmaps to our buffer specifically, so we can flip them back, and we just use this thing. And my question should be like, is if we use this route, all the kerning and all that stuff should be correct, or should I take into account something that I should, from where do I start moving, you know? Because if I remember, let me go and find my code point bitmap subpixel. Nope. Make code point, yeah, there you go. This is a 1. Oh, so yeah, it's the same. It's the same as the one we're using right now, but it's just had some extra stuff. We probably don't care right now. For example, the pixel stars and all the stuff. Since we're positioning them ourselves, I believe that we don't need it. You know, the only thing that I want now to answer myself is okay. Um, let's say that we want to. There was a place where it tells us how to position the bitmap itself. This is the one we're using. We use the thing. Okay, so we got the region with the offset, so we can probably use these offsets. I don't remember how to put it, but there was another here. The bitmap and location to place the bitmap top left is left side bearing times scale IY0. So we can use, well, we already have it here, isn't it? So we can pass this like this. And probably uh, oversample. What does oversample mean? Oh no, it's just, it's not that one. Is this the shift? This is the scale. We have a stride. We have a really high. Okay, let me go back a little bit into this. There you go. Compile. Have kerning bands. Alright. And probably now think about it, I mean, we don't want the glyphs to have the font scale added here, since we could do that on the other side, you know. Probably want to do it this way, you know, and then we have that and we do it right here, you know. So we always get the current font scale if we want to. And also, no, I step back. The reason that I want it this way is because since I mean, the notion that we have right now, part of it is that the font itself, it's gonna be pre-rendered and cached as a certain font scale, and we're gonna grab the whole side, you know, the whole code points. So it has sense to us to just adjust it and keep it that way, you know, so that every time we grab it, we know that this is the scale for this specific glyph and for this specific scale, you know. So this glyph has this scale, and that's all, you know. So we don't have to care too much about that when this thing happens to have it. All right, that sounds fine. Okay, so the thing that I was thinking is like, okay, trying to use this one correctly, because let me see, I'm gonna say if 0 here, and I wanna do this without pushing, you know. I just wanna say something like this. So I wanna see if this call allocates it right away, or if it's gonna just crash out of it, yeah. So we like to close this, and I will get the mono bitmap. Alright, and I want to step back here. Alright, we got the box pixel that it's, whoa, oh, it's because it's 32, isn't it? Yeah. And the y0, y1, yeah. So what about the mono bitmap? It's null. Okay, let's go to the next one. We got it. What about it? 31, 22. what about if we just do it with this, something like this. We got the output. No. Got the code point. So there you go. We didn't get, because we got a 0 in the scale, so yeah, it needs the scale on both sides. So it does basically this. Oh yeah. So here, for example, here it goes. The space character is gonna have 0 everywhere. Okay, so x0, y0 gives me the pixels that they're gonna be touched for the rasterizer. So this needs to scale, this also needs to scale. So this is correct. So the width is 9 and the height is now 59, which is fine because it's that thing. And yeah, it expects this to pass the pixels that we didn't pass at all. So yep. Alright. So let me pass the thing that we were doing before. Here you go. So he makes this call that's about font info, assign core output, and where's the stride? This is the stride. So he already uses glyph bitmap box of pixel, which is this. So let's say that got that. Alright. So my question is why, I mean, if it's the same as get code point bitmap and we pass the high, so let's see if it's the same, you know. I'm gonna do this, and we know that for these, how's this called, this character, the it's not the question mark, the other exclamation mark. Okay, so uh, let me use that, and we know that it's 9:59. So now I guess we can use this. For the first one we don't care too much. For the second we do. And we see that, yeah, the width height is 959 is the same. But he gets us the mono bitmap. And the mono bitmap, we have the address. There you go. We have the whole thing filled, which is what we should be expecting, I guess. I mean, so we probably are missing to pass something else, you know, like these are the shifts, so I don't think these are probably the strive. So yeah, I mean, well, yeah, I think we should use the other way around because this is the proper way that we want to use it instead of this. instead, you know, because yeah, I mean this is like we want to render it, and we're just gonna get the metrics to do it ourselves. So let's see if we can do that. Well, yeah, it all makes sense. I thought that we could also do that with this, but um, I guess since I mean this whole thing is to literally get the position in the pixel space and render it into that buffer, you know, which is another way to go. But yeah, okay, so we got it and we render it using this. Now the thing that we want to do is to get this. In fact, the kerning we will need to do it as this. Well, since yeah, we can do it this way, I guess. I can say net scope point. Two. Net scope point less than. And in fact, we can do this. Um, Min code point. Extract it. for now I'm gonna put it right here. And I don't know how do we want to store the current table, since I mean basically it's gonna be a bidimensional array. Well, I mean that can be a way to go, but if we're gonna support Unicode, we should have this kind of a. I mean we don't want to have. I mean we're gonna start having like this kind of a sparse structure that we don't wanna. We want to consolidate. So can have some. Oh my god. Can have something like this. Let me open Scratch. I mean the idea is gonna be like something like this. So for this it's gonna be like dance in this part, but then if we are like these symbols or kind of weird characters, shall know. I mean let me take a look at the Unicode table, because if you think about it, I mean here are the whole symbols for mathematics. Well, I'm sorry, for for how is this called? I mean symbols that you use in code and which the debugger usually uses. I mean basically it's gonna use, I mean essentially it's gonna use these ASCII characters. I don't know what other characters should we use. Unicode character list. I mean there are all this kind of fancy stuff. Okay, these are the normals. So these are the others. And I mean the other reason that we wouldn't necessarily need to extract it is because I mean probably the font is not gonna have the glyphs for it, you know. I mean the most probably thing is that the font itself is not gonna have the glyph for all the symbols, you know. So it's kind of, I don't know if useless to have them, you know. I mean even if the code itself, I mean if you code using some kind of special way to do it, I don't think so. Yeah, I don't think. I mean, especially, yeah. I mean, we're just. I mean, the debugger just uses the code letters, and to write some kind of, to debug and inspect those variables that are written using the ASCII standard. So I mean, does this is a question? You can see use can see code use non-ASCII character set. I mean you can, oh yeah, I mean you can read them and you can make a how can I say, you could make a parser that understands that. What I mean, yeah, you can do that of course, but I mean uh I mean even though I mean you can read them, but what's the purpose of? Or I mean my question is, why should we want to print these characters at all in a debugger? Yeah, I don't think so. I mean we can change it, I guess, but I believe that if we're gonna just use ask him, we can have it as a contents table and that will be fine. Yeah, where is it? I mean if you just used, I mean even if you use all this stuff, you know, even that we don't use this list for, but for characters and selecting code points itself, uh, yeah, I mean look at 32, like a 95 by 95 table. It's about, let me see, it's gonna be 95 by 95, 925, 9025. So with 9025 entries, that's about 9k. I think that should do it. it's not huge. A 9K table for glyphs. So yeah, I mean, we can have this. As let me see. Oh, and you know I'm gonna do it like this: 128 by 128. What about 256 by 256? How much would you? C5536. That will also make it. Uh-huh. 128 by 128. The 163084. 16,384. Yeah, I mean, well, why not? Oh, oh, look at this. I thought that, for example, the greater than equal or less than equal. Probably we want those, or the ors. I believe they are here, or not. Yes, here's the ors, or the um, mathematical ways, mathematical expressions are here. Sure, not the whole sets, but yeah. Oh well, for example, mathematical things we could add them. Omega, summation, pi. Let me see. Mathematical, Unicode. Yeah, yeah. Almost all standard characters used in mathematics. Unicode Technical Report number 25 provides comprehensive information about character repertoire, their properties, and guidelines for implementation. Here you go. They are in 2020. Yes, this is where is pi? Where is pi? Where is pi? This is like greater equal. This is the same, isn't it? I mean, it's the same as. Oh. No, man. Yeah, because it's 2020x. No, but these are not that those ones. These are this is pi. No, this is product. The product. Where is pi? What are those symbols, man? Oh, and this is the mathematical way to write those. That's the fancy way to write glyphs, I guess. This is Unicode. Little like symbols. Well, probably we don't need all these, you know. I mean, probably we would like to add where is it? Well, yeah, we need this geometric shapes. We don't need anything of this. Oh yeah, I know. Mm. Yeah, yeah, I was thinking that this was the one, but no, in ASCII. I mean, the parser, the C compiler, it reads this, you know, like a double double. It's not like this. It's not the same as the symbol that double double. You know, it's different. It's just parse like this, uh, or operator. So yeah, this is not important at all. We don't need anything of this. Even this, we don't need it. We don't need this at all. We don't need this. I was thinking like probably we want to add some kind of mathematical symbol structure, so you know the bugger can do that. But I don't think it's gonna need more than this, you know. I mean, even this, I don't know if we're gonna like do it this way. I mean, we could. I mean, for example, the square root, the cubic root, or you know, all these things. But probably, because right here we just have, I don't know, we don't have even things that we need. They are just like letters from Latin letters. Oh, the shapes, probably those we need. We also need, oh, here's the square root. Look at this. We got less than equal, greater than equals pi, summation, omega, I don't know what's this, dash, or a line, question marks, just one question mark because the other we don't have it. So yeah, I mean, I don't see like literally too much of a useful thing to have Unicode support. I mean, this is not like a an editor. I mean, if you have a text editor, probably you want to support Unicode. That seems fine. But if you're doing a debugger, I mean, that probably doesn't need. So yeah, I mean, we can take it. I mean, we can check it later, but we can have. I mean, we're gonna add. I'm just gonna do it like sparsely for now, but I mean, we don't care too much. We're gonna have some kerning table, and probably for something like this, since we already support 4096 glyphs that we probably never we're not gonna use at all. So yeah, I mean, probably with some kerning pair like this, and yeah. So it's gonna work like a hash table, probably. Alright. We can do it with this, and let's say that we wanna say Yeah, I think next code seems fine. So we probably can think of for the simplest thing possible. In fact, we can do this. This. Hmm. But if we move, imagine that we keep moving. We'll keep changing the value that we're pointing to on each iteration, and then we'll have a pointer whose value is being modified. So yeah, I mean, we can do it with this, or we can do it like this. The thing that also we need to do is to point back. So if we say like, do say kerning table cut point, let me see. Push struct until the debug state. And we want a kerning pair, and we want to say that we have this, you know. Fact. So we can have it like this. We can pass it like carrying value. Kerning pair. We don't have a push track. It's fine because we can do something here. We can Let me see. Here's the for, here's the if. Here's the, this is the for, this is the if. This is the if, the other if, which is fine. There you go. And there you go. We compile. Since we are running, I believe. Alright, so basically we add the kerning here for each code point that we add. And right now, I mean, it's not even sparse because we don't have a, I mean, we just can add like 4096 and that's all. The thing that we can do to make it sparse, I don't know if you want it, I mean, we can do it trivially, just changing this from an array to a single linked list or something. But for now, I guess that's fine, because that gives us some possibilities for array searching and that stuff. So if we want to use it, what we can do is to let me see what we can do here. Where is it? We got the kerning. We can do it. And I think, I mean, you can pass it and you're gonna get it. If you don't get it once, you will add it, which is fine. So let me move this a little bit more upwards. Probably here. And we wanna render the text. So when we render the text, I wanna do the kerning also. And this is get kerning prepare, and we have the debug state C0 C1, and that's all, isn't it? Yep. Alright, we got the scale, and this is on scale, isn't it? So we probably we don't want, we want to do it right here. So yeah, I mean, I like this way because it's not truly dependent. And for example, well, this will get me the kerning pair. So I don't know if we want to just do it like this, I guess. If we want to modify it, but we don't want to. Yeah. So probably this can be called found or result pair, probably pair pair found, and then we return pair found kerning value. Alright. So we can do that. We're carrying for pair, we get it, we multiply by the scale, get the edge advance, and probably this wants to be like this also, so we can match it. I like that way. This is the glyph. We multiply by edge advance, and this we will add it here. And the left side variant, I don't know where to put it. Probably we have to you do something like this. In fact, I don't know what is the edge advance. Probably we can do something like this. So we could do probably uh, uh, probably want to do something with this. for example, when we have, I don't know, like this kind of set of sizes, I want to try to define that so we can see how to do it, because right now it's not so easy. So what we can do is to do something like this. So this is on scale. All this is on scale. And we can have something like this. Because if you think about it, sorry, we have a font, and it has like the min max, and we also want something like I don't know if this is here or more generic. We can put it on a more generic way. Glyph sizes, I guess. So for example, we can have glyph size count right here, and this will have like meanings for each glyph size. So we have the min max, we have like a set of like a set of glyphs for each size, so probably we can have something oh, here we have it, the scale table. So the scale table, let me think about it. So instead of having like this, you can do this. And we probably want to have the array of glyphs. Where is it? There's a glyph. What about having something like So we probably want to have as a glyph meta, or glyph matrix, glyph matrix, I like it. And this probably wants to go, since we now have just one per glyph, and of course I don't know if we want to like load the whole stuff at once, or I mean probably want that like asset stream the things as needed. Probably want to have something like that, but for now it doesn't matter. We can do like we have a code point, and this is gonna have something like we want to freely change between scales without having to replicate the data for the glyph index, you know, because we already have the scale. I mean, we have the like the current font scale. I mean, this is like the font scale, but yeah, we probably want something like this, you know, glyph size, current glyph size, and this is current font scale. Which is not the font scale, but yeah. I mean, this is totally independent. Doesn't has to do with how we're going to store this, like the scale table. So probably we want to do something like scale table and you know, I mean, the code point glyph is gonna map from the code point to the glyph metric, so probably gonna be like glyph metric index, something like that. And this is gonna be the where are the glyph metrics? These are, let me put this here. These are the glyph metrics, basically the horizontal bands and the left side bearing. And since those are on scale, I mean, we're gonna have something like this, you know. Let me draw it with Milton. It's kind of hard to visualize, but let me use the powerful Milton. start here and say that I want to, I mean, we're gonna have something like this, you know, where here are just all the glyphs for a font, you know, so we have font, and now we don't care if the font has many glyphs, sorry, many font types, you know what I mean. I mean, if it has like this, it's like a class of, or like a group of font, a family, you know, like they call it font family. We don't care about that. What we do care is that, okay, we're gonna have an array of glyphs, you know, and those glyphs, you know, it's gonna be something like, let me see, I don't know, some table, you know. And since we have, and imagine that we probably have, these are the code points embedded here, you know. So we have an array of glyphs for font, and we have embedded the code point there, you know, somehow, because we don't care too much. And then we have another, and we have scales, you know, and scales probably can be the same. I mean, we just added more and more and more, so we will have something, it's gonna be the same code point, but it's gonna have a scale, you know. So I mean, it can even be something like this. Scale index, something like that, and it will be like this three-tier data metrics thing, or meta search, that will like, oh, you know, I want this code point with this glyph and with this scale, which is fine, I guess. It's like, oh, you know, I want this thing, you just give it to me. Okay, that sounds good. And since this is all with code points, it doesn't matter, you just need, and then we can do this like this. So let me move this back here, and then we have that, this is a cyclic metrics, we'll need this, something like that, and then we want to so we can do something like that, and then we can do something like this, you know, like it can be another hash table, I guess. Since now we have like this three-tier thing, so we can have the hash function, and the hash function basically is going to have these things being added, and the things that Yeah, I mean, I don't think it's such a problem with having the hash table. And the good thing about having the hash is that it will make us kind of easy to load and reload. Well, um, to find them, probably not so easy to delete them, but uh, if we wanted to delete it, if any. But um, mm, so give me the glyph. But this is more like size index. So we don't care about, yeah, the scale is the thing that we want. So the size index, the metric index, and the code point. Yeah. And we probably want how do we want to choose font glyphs? Okay, it's a good question. So you think about it, I mean, we'll have something like this, you know. So we have a code point, and in fact this can be set. I mean, we can have how can I say, well, we have a code point, the glyph, and the size, and we can have many sizes for this, as well as So what if we do this, you know? Let me, this is some kind of hypothetical thing. I don't know how it's called, and this is gonna give me like a mean, the mean glyph index. I mean, this is a way to use it, you know, to have like this kind of distributed table that tells you everything about a specific glyph, you know, its size, its metric, and the call point, you know. And another way we could be is to have the min glyph index and the max glyph index. No, I don't like it. I think that's good. Yeah. All right. So yeah, the point here is that we will have this. We have two tables basically: the code point glyph size, I guess. I like code point glyph. Yeah. The kerning table, the ASIC glyph metrics. That basically is gonna give us that. And yeah. So what we want is to have ASIC glyph metrics. There you go. So this is gonna be your glyph metrics. I mean all the glyphs that we can have, you know. And probably want to do something better, but we're gonna keep it this way. It's gonna be the glyph count. This is gonna be isolated. This is gonna be the cglyph table. Is basically the entries for how the mappers goes. And I don't know if we want something bigger, but I don't think so. We will test, and then we will need the glyphs itself, you know, the bitmaps. And the bitmaps, I want to add that glyph data I don't know, 4,000. $4,096. Since we're gonna have the index, where do we have it? Here you go. And we can do even something like this. And that will be it. Let me transform this. So instead of having, well, this is the bitmap, something like this. No, I'm sorry, no, here, like this, and probably you know, probably now we have a code point glyph hash table, and this is gonna be code point glyph next, code point glyph next, and this is gonna be glyph metrics are in scale. Yeah, I don't care. So now that instead of having this, we'll have basically this. It's gonna be Okay, let me go back here, and let's say that we want to gather. For now, I'm gonna pause on this side stuff because we're not doing that specifically. So let me forget about, where was it? Yeah, the last thing that I was doing is this, because I was thinking like, well, probably we don't want to, we want to attach that, but probably I prematurely did it without doing it completely. So what I would like to say, it's that, where is it? Here is the get kerning. Here we render it, and this is gonna have a scale. That's good. And this is gonna be like this. Get H advanced is the one that has it. Right. For now, I'm gonna do it the way we had it, just for testing. And to see that we got something. And tomorrow we'll do the sizing. There you go. And now here we'll need to go in for scale, see the table, wave can, see waves, have the kerning table, and that's all she said. In this scale, let me do that. And if we want to do it here now, where is the place that we design here? We don't need to do this at all. Right here. And G. Okay, so let's see what happens with the thing we just implemented. Let's see how it goes. There's no kerning for the one that we got. and then we get the kerning preparer. So yeah, right now we add it even though it's 0, so I don't know if we want to do something about it. So yeah, we got it. And probably, I mean, the thing here is that we are not using the first pair. Sorry, what's next? So we probably want to do something like this. Mm, I mean, right now we have like a row of 4096 values that they are gonna be 0 all the time. So we probably, I mean, how to fill it, how to fill them also. So first pair, I mean, it can even be something like this, you know. Yeah, I like it more. So this is gonna be something like this, and that way I will have the thing I want, so that we have a current table coupon. So in fact, now it would be something like this. Now we can do it like this. So we have array pointers. Since we have an array of pointers, forget about this. I'm gonna do it. Oh. So we have a pointer, an array of pointers, sorry. And what we want to do is to move along. We probably will need this. Well, we have iter, and then it's gonna be moving, you know. Iter is gonna be iter next, iter next, iter next, until we get to the value. If we get it, well, we get it. If not, we can do something like like this. We push it, do it. It's gonna be the first pair. And in fact, well, the thing that it's pointing to, basically. And now we can have so something like this. Let me see if that's correct. I mean, I was thinking like, how can I get rid of iter? Since we have a pointer to the pointer, I'm gonna have something like this. We have an array of pointers. And this is gonna have, this pointer is gonna point somewhere in memory. And it's gonna have a pointer to the next value, and this value it's like the, okay, we have the address of it, so you can have like address, I don't know, A, and then here is gonna be the other. Yeah, sometimes it's hard to visualize the pointer to pointers, but it's just basically I have a pointer that points to this value, and since this pointer, I mean, points to the first to that element. Imagine that we got, I don't know, B. So this pointer to pointer is pointing to this location, isn't it? And in that way, well, I think I like the iterators, and I mean, at least we know that it's gonna be moving, and per fan is gonna be either, if not per fan, we're gonna push this track wherever, and everything is gonna be done the same as we did it. So let me see. So we got a first pair, and we got a kerning that's it's gonna be null. So we don't have anything at all, and then we say, hey, you got it? No. Okay, push me, and we have a first pair. Is next, it's gonna be null. We're gonna get a kerning value, we set it with next code, that is 32 if I believe, and we gotta like the first pair, it's gonna be the per fan, which is correct. The per fan kerning value, it's gonna be that, which is correct, which is 0. Alright, that worked. Let's go to the next one. We add it, got it. Since we're in the same one, we're gonna get an iter that has the first one. Yep. We don't have it, we go to the next. We don't have it, we add it. Next, it's gonna add it to the head. Then we have the next coupon, first pair, third pair fan. So the first pair is gonna be blah, it's gonna be 33, 0, 0. The next is gonna be 32, 0, which is another kerning point with 0. So yeah. Is there a kerning value that's not 0? So now we have a code point that it's 33, and we add the whole thing, you know. Okay. So there you go, we have the whole thing, and right now it's pretty much nothing. Have 32, and this probably is gonna have nothing. The 32 probably is gonna have I don't know if it has something. No. So I believe there's no kerning at all. Okay, I will clear screen, blah blah, under the text, kerning advance, it's 0. Well, I stepped into it, but So we're looking for the next scope on 101. This is not, but probably we're gonna get sometime. Yeah, we got it. We got it. So hey, now it seems better. Although, yeah. Okay. I wasn't expecting this. Yeah, it looks good. Thanks to Mr. Sean Barrett for going on this way. Now my thing on doing this is probably, let me see if I can modify this a little bit so we can see how it all like works around, you know. I want to go here and I want to go to, I don't know, I don't know, man. I mean, yeah, probably, I mean, that's the way it go. I mean, let me write in the scratch so I can scratch. Forget about this. And we're gonna write hello world, right? There you go. So he has a bigger space in between the ones. For example, the R and L, they look the same, but the L and D, I have it a little bit more constrained. Equally the O and the R. So let's see. Well, I wish I could have some kind of change back to the other change back. I can change it like here. Oh man, it's gonna be hard to change it here, isn't it? Yeah, it has to be like this. There you go. Alright, it's good. Let me go like this. And the thing that we did here was that left side bearing, we get that here. So what about doing this, you know? There you go. And what about this? Well, that doesn't change anything, and probably because mono doesn't have any kerning at all. So probably that means that mono is gonna be not a good test for kerning. So you can probably load another font so we can test it. Another way that we can test it is with the notepad, I guess. And we can test with this. and we can get the fun. Let's test. I don't believe he has mana. Or is it mana? How it's called? Liberation mana. Oh, there you go. There you go. 20, 20, 20, well, 28. Well, a little bit more bigger because liberation mana. Where is it? Where is it? Probably bigger. 72. There you go. There you go. So yeah, I mean that looks. Let me. Oh Jesus, Jesus, Jesus. I'm sorry. I didn't mean that. There you go. So yeah, I mean probably. I mean, for example, there you go. Yeah, that looks better. Yeah. So yeah, I mean, well, wait a minute. For example, yeah, it's a little bit bigger, I believe. 66. There you go. So, I mean, for example, the R and the L, they look a little bit spacey, whereas this looks a little bit. Well, this looks the same. This looks the same. For example, this has a little more space between the O and the W, and the R and the O. You know, they're like more that way. If I'm looking right, I don't know. But yeah, definitely with the left side brain. So let's say that we have this. Now let's try something different here. I will load another font so we can test it. I mean, because I don't know if I can even test it back, you know. Let me see if any. Run. Nope. It didn't enter at all. Well, well, if we put a breakpoint first. Nope. So yeah, it doesn't seem to have any kerning at all. Any kerning. Let me try with another font that I believe it should have kerning. So probably it can be where is it? Right here. I wanna this. And I got the breakpoint, so let's see. There you go. This has kerning for 65. What else? 84. No, sorry. I'm sorry. What's code point? 32. Okay, 3265, 3284. Code point. Next code point. 84. It has 39, 49, 49, 62, 62, 84, 87, 182, blah 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 blah. Good. I like that. Okay, this has a lot of kerning, which is good. And alright, now let's pass into the rendering. Okay, this is Arial with some kerning. And let me see what about without the kerning. And this is with the kerning. How does it look like? Yeah, it's a little bit, but man, that's the difference, man. That's the whole difference. Such a little bit. Such a little bit. But I mean, I don't know if it's kind of weird because the H and the E and I mean, the world looks good, but the H, it feels so lonely. Let me write this with Arial. Arial normal in a 66. So yeah, it has some kind of missing things there. I mean, for example, he has more kerning here. Well, no, it's the same. Or yeah, the O and the R, these are more separated. The R and the L are more separated. The D is less separated, and the H is a little bit less separated. Probably that's too much. And that's a lot. So probably we can use the offsets. Let's try that. Let me see. I can use the offsets to use them, so that we have X offset, I don't know if we want the Y offset, but X offset. So we can do something like this, I guess. So we can have something more like this, so that where are you? Where am I? Here. And then we basically do this. Well, basically scale coupon. Or this is not. And then we can choose a right. Then we can basically push this right here, which was the first thing that we made. There you go. There you go. So bytes per pixel, we already done that, and I think that's fine. And instead of passing out this, we will have let me see, a bytes per pixel. We have the glyph, and right here we need the glyph index. That's the one that we get from here. So this will give us something like this. Pass the font. That's should be font and the code point. There you go. So we probably yeah, probably we want to do this like this, and we want to have the thing that we had before, but so yeah, it wasn't bad, you know. And then yeah, I prefer it this way. So it would be the same thing we had before. um, so we basically do this, then there you go. There you go. And this would be this. We don't have the width and height, so we can do this like this. fact, well, I can do this here. So we do it that way. What we could say is that instead of having it like this, is cliff subset. Probably that feels a little bit nice. Yeah, I guess that was it. I think that was the thing was missing. So it's minimal, but so yeah, something like that. And let me go back just for now. Well, I like it because this has a kerning. So yep, I think that's all for today. If you would like to ask some questions, please post them on YouTube or on Twitch, on Twitter, and I'll be happy to answer them. For today, that will be it. And yeah, we have now set the kerning for the fonts, which is fine, even though it's such a minuscule. But hey, man, each bit counts, you know. Each bit counts, and for fonts, especially as we want to handle them properly, and that's what we did. Yeah, and probably we want to check it more because I don't know. Uh, Probably the x substitute shouldn't be there. Yeah, I don't know. I have to check a little bit deeper uh, the SCV true type library so I can check it. But for now, that'll be good. So yeah, thank you very much for coming up, and I will see you all on the next stream.